Welcome everybody to our third meetup of the week. This is a big week, next week's a big week, and the week after that it's even bigger. As usual, my name is Bart Farrell, and I'm lucky enough to be celebrating another Data on Kubernetes meetup. Today was a very special person, and I want to say very special, I mean very special person. We've got an hour, we've got a lot of stuff to cover. As usual, DoK, can we get the links on the screen? If this is your first time in the Data on Kubernetes community, please remember that we have LinkedIn. Yesterday, we broke 1,000 people on LinkedIn. Yes. And now we already have 1,050. So that's going really well. If you're not in our Slack, please get in our Slack. That's where you can connect with wonderful folks like Webb. You'll find out that his company is also hiring. We have job adverts. We have people sharing knowledge, asking questions, interacting with each other. So please get in our Slack. You can also find out about all the other stuff we have going on Twitter. And speaking of stuff that's going on, very special announcement that I've been saying a lot, and I will say again, is that on May 3rd, we'll be participating in KubeCon with a co-located event. So DoK, can we share a screen really quickly? If you are not registered for KubeCon yet, you can just jump into the CNCF website. Big shout out to the CNCF. As you will see, we have the Data on Kubernetes Day hosted by the CNCF, sponsored by our good friends at DataStax. We've got over, I want to say around 10 talks confirmed so far. Tomorrow, we will be finalizing the call for papers. If you have an idea for a submission, we've got the links in various places also on our website, or you can just contact me directly in Slack. I'd be happy to get that to you. So we'll be deciding the final talks, end user talks that we're going to be including. But like I said, you have all the info there. If for whatever reason you're not registered for KubeCon and you would still like to attend, we'll find a way to make that work for you. Our event is 100% complimentary. It's totally free. There will be a fundraising component for an NGO called The Last Mile that we've collaborated with before that helps incarcerated and formerly incarcerated folks learn programming to improve chances of social mobility, and once again, knowledge sharing. We've got that on the CNCF website, and then also you can see the schedule that we have so far on our website, DoK Community. As I said, this is a provisional schedule. There's still maybe some changes after tomorrow when we decide on the end user talks that we're going to be having, as well as a talk about governance for the Data on Kubernetes community as we move forward with our integration with the CNCF and all that good stuff, right? So now we're done. DoK can stop sharing screen. Thank you. That being said, we are speaking to a wonderful person who looks like he is inside a beautiful library. But there's much more exciting to Webb than just that. Like I said, I'm so excited for the first time I'm standing up. Normally I'm sitting down for these things. But we talk a lot about, we were just talking about before we got started, we talk about cloud native mentality. We talk about Kubernetes native mentality, what that means. When we talk about historically speaking, a lot of times we're making references to Borg. Well, today we have a person who actually was working in Google when Kubernetes wasn't Kubernetes, and it was Borg. Webb is a founder, a product manager, an investor, an advisor. You do lots of different things. You've worn many hats. Welcome to the Data on Kubernetes meetup, Webb. Who are you?
Bart, thank you so much. Thank you so much for having me.
Thank you.
Huge fan of what you're doing with the community. Love the energy, love the excitement. I'm so proud to be here. I'm going to start with sharing some slides, and I will do that now.
Okay, good. But first of all, where do you work?
So I am a co-founder and CEO of Kubecost.
All right.
So we'll talk about what we do, but so much to cover here today that's super exciting to us. We're going to be talking about cost monitoring in cloud native environments, specifically, running Kubernetes, like really large scale data pipelines and Kubernetes deployments. We're going to be talking about open source ourselves, projects like Prometheus, Thanos, all that great stuff.
Very, very good. As a reminder to everyone, feel free to ask questions in the chat. Webb, you won't be able to see them, but I will. So we can get to them on the go, or we can always continue the conversation in Slack. That's no problem. But anyway, go right into your material, Webb.
That sounds excellent. Yeah, stop me at any point with questions, Bart. And all questions are fair game today. So anything that's on your mind, happy to talk about. So with that, let's dive right in. So what is Kubecost? Kubecost is a cost management platform built on open source for teams running Kubernetes. We're going to talk a little bit about it today, but We don't just provide with the Kubecost project visibility into Kubernetes. We also give you visibility into spin outside of Kubernetes as well. So we want you to be able to have a holistic view whenever you're thinking about cost management, cost optimization, et cetera. So how do we do that? We do that by focusing in 3 areas. First and foremost, we want to give you spin visibility. So this is about helping you answer really important things like, what am I spending per project, per pod, per team, per department cost center, whatever is important for your team or your situation where you're running workloads. Once we get this visibility in place, we want to start thinking about optimization, right? So how do we give you insights or dynamic actions to where you can right size your infrastructure, optimize your infrastructure to where you're achieving this nirvana or perfect balance of cost, reliability, performance, et cetera. And then we don't want this to just be a one-time set of optimizations, right? We want to think about managing efficient infrastructure over time. So that's where this governance piece comes in. There's a lot that the Kubecost project offers today with recurring save reports. Maybe it's implementing like a showback or chargeback program. Maybe it's budgeting or alerting or anomaly detection. A bunch of different tools available kind of for different use cases. And we can talk about some of those today. So that's a really quick kind of overview of the kind of different parts for a holistic like cost management solution. I think one thing to point out is like, it's common that we see people kind of get stuck in 2 modes when running Kubernetes, and especially running Kubernetes at scale. Part 1 is just kind of not having that visibility in place, right? Like oftentimes when we first start talking to teams, they're largely flying blind in the sense of they can't answer, say, what is the cost of this application or this project, this namespace, or even these clusters, for example. We really, really focus on that as kind of part 1 is get that basic visibility, that basic transparency, allocation, accountability in place before we kind of move forward to like optimization. And then once you get that visibility in place, oftentimes it's pretty straightforward to start thinking about right sizing, whether it's infrastructure, workloads, scaling dynamically, putting those in place. Oftentimes there can be, technical complexity depending on the situation, but this is actually pretty straightforward for a lot of situations. It's really kind of problem area 2, which is doing this on an ongoing basis, right? So, if you have your infrastructure perfectly dialed in one day, how do you make sure it maintains that state? So you're not showing up, once a month or once a quarter, realizing that you're overspending by 30, 50+%. So those are kind of 2 of the most common kind of patterns that we see for teams in a lot of different environments. So quick background on us. We launched a project, the open source project, in early 2019. Before that, my other co-founder and our CTO were both at Google. Bart mentioned we were working on monitoring projects across a number of different like platforms, like Borg or internal infrastructure at Google before Kubernetes days. Then like Google Cloud, as well as like external dev tools. So it's been amazing to see the like evolution of this community and technology going back to pre-Kubernetes experience at Google. One thing Bart and I talked about a little bit was kind of my early exposure to the platform, and we can talk a little bit more about that. But it was like early 2015 where one of my teammates joined this really interesting project called Kubernetes. I believe she was the second PM on the team. She was actually my first manager. And I remember, I will never forget the like first lunch that we had where she was either about to join the team or she just joined the team. And she kind of said, mark my words, this was going to be big. Like the Kubernetes platform is going to be huge. And I remember that was a turning point for me in terms of like seeing the potential. And I have to be honest that I did not realize that it would be this like explosive and this pervasive.
That we would be talking to each other today.
Exactly. But I do have to credit Aparna Sinha for allowing us to be talking today on my side. I think up until that kind of conversation, I kind of thought about it was that, we were going to kind of be open sourcing Borg, externalizing the power and also kind of the complexity that was Borg. And I kind of thought at the time that, wow, that sounds really cool. Maybe there's 1,000 companies out there that would be a fit for. I was wrong, and Aparna helped me realize that millions and millions of developers would be interacting with this. So incredible to see. When we talk about Kubecost, we're actually monitoring a lot of Kubernetes environments of all shapes and sizes across many different platforms. So like more than 1,000 active deployments today. A lot of these are at AWS, Azure, GCP, but we actually have a lot of users running on-prem. You can even run Kubecost in air-gapped environments, a growing number of users doing that. And then really this long tail of other cloud providers see a lot of deployments there as well too. So tons and tons of different environments where Kubecost is deployed today. So with that, let's talk about how this is used. Like, what in the world is Kubecost? What does it do? And we're going to start first with kind of this visibility piece, right? And when Kubecost thinks about cost visibility or spend visibility, we think about three different areas. We think about in-cluster cost, we think about external cost, and we think about shared cost. And in this case, we show those kind of all rolling up to a set of namespaces, and then this project Calypso, which is like a collection of namespaces. So when we just talk about where do we collect or where do we ingest data within a cluster, and all of this data lives in a cluster, we'd be looking at a number of in-cluster data sources. So leveraging cAdvisor, leveraging the Linux kernel, node exporter, a number of other different, like the Kubernetes API directly, all of these data sources coming together to build these models to say, here's the cost of a container, a pod, a deployment, a stateful set, et cetera. And then once we have those basic building blocks in place, again, going all the way down to the container level, we can do any aggregation of interesting collections of workloads, again, whether that's by namespace, by project, or anything else. So that's kind of the in-cluster piece. And again, this is memory, compute, network, GPU, storage, et cetera. But it's really important to not just think about cost within a cluster as kind of isolated from the rest of your infrastructure spend, right? So there we would actually integrate and ingest data from your cloud provider or your cloud billing data set. So there you can see this holistic view of every stateful set or pod or anything that is using external resources, whether that be a load balancer or a BigQuery data table, S3 bucket, RDS instance, you name it. This would allow you to kind of holistically see the cost of running a tenant or the cost of running an application. So then part three is it's really common to have shared resources, right? That could be a monitoring namespace within your cluster. It could be sometimes even we'll see teams add their own infrastructure engineering team's time as a shared cost that they want to distribute across tenants. So Kubecost has a number of different ways of doing that. You can split costs evenly, proportionally, et cetera. But then this is really, again, about kind of getting a balanced and fair perspective of cost visibility or spend over your environments. So that's really talking about all these different data sources. Kubecost would pull them all together and again present to you a holistic picture of spend, not just in your cluster, but outside of your cluster as well with these external costs. So with that, I was planning on jumping into a demo.
Do it.
Let me know if there's questions while I spin this up. But if not,
I do. I mean, just in terms of context, because we have had conversation with Sergio from Red Hat. I mean, obviously looking specifically at OpenShift, but we've had conversation with other folks as well too about cloud costs in general, but also with Kubernetes. Is it? It's something that's come up multiple times. Like, are we talking about questions of governance, responsibility, what things should be, inside from the get-go? But these costs that we're talking about, exactly how much money, are what kind of numbers are you seeing?
Yeah, I think, when you talk about just deployment size, we have users of Kubecost that are spending, hundreds a month or maybe thousands a month, up to like tens of millions of dollars a month. So a huge range. Obviously, like as that number grows, teams tend to care more and more. What we have seen is like once you're spending like $100,000 a month, it's typically like worthwhile to make an investment here because now you're starting to talk about multiple headcount in savings commonly. And I would just say, back in the envelope, it is very common where teams are able to reduce spend by greater than 30%, oftentimes greater than 50%, when they start really reviewing costs closely. So as that number grows, you can think about it as like the opportunity cost or the cost of kind of not taking action tends to grow as well. We tend to see, again, kind of around that 100K mark, teams take this very, very seriously. But we've also seen tons of, I think kind of sadly at this point, war stories where, your regular, cloud bill is relatively small, but you spin up a really large GPU training cluster and you accidentally leave it running all weekend. And it's a very expensive mistake, right? Like, you accidentally spend like 50 times your average cloud bill in a weekend kind of thing. So definitely varies, but in general, that's kind of the mark where we see teams taking this really, really seriously.
All right, perfect.
Cool. And let me know if there's any others, but if not, I will dive into this.
No, you just have a fan who said a comment that Kubecost is great.
Thank you very much.
Nice shot. Oh yeah, that is from Sergio from I was talking to who was on here from OpenShift. So anyway, thank you, Sergio. Very nice of you.
Thank you so much. It means a lot. That's why we do this. I really appreciate the feedback. So we're taking a look at a Kubecost deployment right now. It's a small staging environment that we have set up. And what we see right away is we have got data for multiple clusters, right? So super common that teams want to see kind of all of their environments, all their clusters totally unified. You can see all of those different pieces we talked about. So in cluster spend, CPU, GPU, memory, et cetera, shared cost, external cost. And so one thing is there's kind of two really common kind of questions that come up when you first see this view. So first is, okay, why in the world am I spending this much money? Or why are costs trending this way? And then also, why in the world is my spend efficiency so low, right? So we've built a UI to where it's really easy to go and answer those things. You truly just click, once, and we dive into the namespace level. So right away, we can see, okay, these are the actual cost drivers from a namespace perspective. We can see efficiency by namespace, et cetera. So from here, we can just keep going. We can dive into the namespace. Here we see every single workload running in this namespace. So deployments, daemon sets, jobs, if there's individual pods, we'd see those running, et cetera, et cetera. From there, we can still keep going and we can see the individual pods that we're running in this particular deployment. And again, here we're watching efficiency as we go to be able to understand, again, what workload is actually driving or maybe even skewing our efficiency. And so from here, we can go the final step and look at these costs all the way down to the container level. I think here it's helpful to kind of talk about how this is calculated, because again, everything that we just showed you, all this cost allocation is built from this most granular level. And the first piece of this is talking to the Kubernetes API to determine the amount of time that this particular workload was running, right? So when was it actually scheduled? When was it actually consuming resources? Secondly is, given the particular resource we're looking at, in this case, CPU right here, how many units of that resource on average over this particular time window? We're looking at 7 days right here. How many resources was this workload consuming? Here we'd be looking at the max of usage and request. So if it's a best efforts pod and there's no requests on the workload, we'd be looking at usage. If there's a really high request and you're using very little of it, well, the scheduler is still reserving those resources for you. So we strongly recommend allocating or billing the request there. And then, this number, which is really important, is like, what is the cost of this unit, right? Whether it's a CP hour, a GB hour of storage, RAM, et cetera. There are two potential sources for this, actually. When you just deploy Kubecost, you can literally just Helm install it. You don't have to integrate it with your environment. Again, all data lives on your environment, so you don't have to share any data. But we would be pulling from one of two sources when you first deploy it. If you're on AWS, GCP, or Azure, we have integrations with their billing APIs. So we would show you the cost of the CPU on that in one standard, or whatever node you're running on.
Sorry, one quick question from Saturday. Efficiency field, the higher, the better?
Depends, actually.
Okay.
So in general, if you have really stable usage requirements and you can predict efficiency really well, you definitely want to aim towards higher. If you have highly variable and or very hard to predict workload requirements, you really want to think about this balance between, again, kind of performance and cost, right? So if because we're talking about CPU, if we just use that example, in this case, we've requested 200 milli-CPUs. So there, if we set that number too high, we're obviously going to be a low efficiency and we're going to be overspending. But if we set that number too low and we do have a spike in utilization or a spike in CPU demand by this workload, we're at risk of being CPU throttled. And that obviously has latency, reliability concerns. So it really depends on the nature of the workload in terms of the predictability of resource needs, and then also the impact of these kind of negative events, whether it's being throttled or out of memory evicted, et cetera. So if you look at Kubecost, when we actually give you recommendations or insights to set these requests or limits, we'd actually be letting you set a quote profile. And there it's if this is an HA environment where throttling is a big concern, right? You want to set this number higher. You want to give additional headroom. On the other end of the spectrum, if this is a dev environment where, hey, it's not the end of the world if things get throttled, you can tighten headroom and look to push that efficiency number really high. Just to give we commonly get this question, just some back of the envelope numbers that we commonly see. 65% utilization from CPU perspective is really common just across many different workloads. If you have either batch workloads or really stable resource requirements, we see that number, up into the 90s sometimes. Most of the time it's, 60s to 80s, just to give some back of the envelope. But again, context does matter there.
Okay, regarding, another question. How do you make the integration with Azure APIs to get the cost using a service principal name or something like that?
Yeah. So two things here. One is we would just ship with a key. So it kind of just works out of the box, right? So we would integrate with public billing APIs based on the key that we ship by default. But then if you wanted, say, let's say you have a special discount, an enterprise discount, or you're using spot nodes and we want to reflect the price of your infrastructure, that's where then you would integrate with your particular cloud provider, like billing data set. And a number of different ways to do that. You could use a cloud formation template. You can provision it yourself and just give like on Azure a subscription ID, et cetera, into Kubecost. We'd have like docs.kubecost would have all that available. But a number of different ways to do that integration. It's totally optional, but what it does is take you from general pricing offered by the cloud providers to your specific pricing. And what we do is we are real-time reading this data from the Kubernetes API. And then as soon as your cloud provider's billing data set is available, we'd actually reconcile to what you're actually charged. So it allows you to have the best of both worlds. We get you kind of real-time, oftentimes within a minute, but very near real-time data from the Kubernetes API. And then we get you that like high grain precision accuracy as soon as your cloud provider billing data set is available.
Okay, we got one more question as well.
Awesome.
You're getting people really excited. People want to save money.
Love it.
So another question from Sardi. Thank you, Sardi. We're gonna have to get you a t-shirt. Also, in terms of on-prem deployment, how does Kubecost determine the cost of workloads?
Great question. So that's this area number 2. You can think about even like DigitalOcean or Alibaba. We would actually perform similar to on-prem today. And the answer once again is twofold. But the holistic answer is like custom pricing sheets. But by default, we give you some assumptions which are based on public cloud provider billing data sets. And we would just say, here is an estimated cost per CPU hour, cost per memory hour, cost per RAM hour, whatever dimension you're looking at. So from there, we actually have a more advanced like custom pricing sheet pipeline where you can actually come in and kind of override those simple estimates and just say, for every single asset in your environment, here is the cost of operating that asset. And you provide this on an hourly or monthly basis. And then based on that, our like Kubecost itself would determine the cost of each individual resource on that particular asset. That's the like more advanced way of, again, kind of a fully customizable, down to every single machine, if you like to kind of set heterogeneous prices for different boxes that you have. I would say that most teams are comfortable starting with just kind of the basic, configuring a CPU hour, et cetera, and then typically progress to that more advanced pipeline if they really want to dial in like a chargeback program or a showback program, where kind of getting down to, the last penny is really important.
Okay. And now that we've jumped from DigitalOcean, Alibaba, we've done on-prem. An AWS question, also from Sergio. How do you split memory and CPU from AWS costs into their own costs? So both double when you use a higher size instance.
Totally. And this applies to other environments as well. What we did was we basically did some analysis as essentially like a linear algebra problem where we basically said across family types, on average, here is the marginal or incremental cost of a CPU. And here's the marginal or incremental cost of a RAM hour. And then we hold that ratio constant. So if on average we say that one CPU costs 5x one GB of RAM, then that ratio would be held constant across any like instance family or any family that you provision a node in. That's fully configurable. We have a lot of teams that set kind of their own internal kind of economy for prices, and just some teams that even say like we want to shift all of our costs to CPU, for example, and RAM is essentially free because we're only really ever bottlenecked on CPU. So that would be able to be done just by a values.yaml configuration change in our Helm chart. So that's the kind of high level analysis that's done. Again, you can override it, and happy to share more there if you want to get.
No, but I think it's good. I think it's really interesting to hear your explanations on this because in a way, you've really kind of got to be we can say a jack of all trades regarding, each cloud provider has its own ins and outs, intricacies, integration, things you're gonna have to keep in mind. So when you're, with the full spectrum of different, customers you're interacting with, you really kind of got to do a lot of homework, I guess, regarding the differences between each one. Anyway, good. Thanks everyone for the questions. Let's keep moving.
Yeah. Just to finalize that point, we do think it's super valuable to have that common language across, right? We have more and more teams that are in multi-cloud, hybrid cloud environments. So to have a unified language where you think about, cost allocation across everything is super important. But that through those questions, I think really got into this number and beyond. That's all I wanted to say in this particular demo. So yeah, we will jump back to slides if that sounds good.
Excellent.
Sweet.
Good.
So let's talk about, we're collecting in large environments, especially we're collecting just tons of data, right? Just cAdvisor alone, typically most teams are scraping it every minute. So you're, sampling usage metrics every minute. If you have, thousands of workloads, it is a lot of data, right? If we go down to this lower level, we integrate tightly with a number of PromQL, and by we, I mean Kubecost project. This could be a Prometheus, a Thanos, a Cortex, M3, any kind of PromQL endpoint is essentially supported. So the way this underlying time series database would work is it is both a source and a sink for Kubecost. So it is ingesting things like cAdvisor metrics, and then also it is we are writing back Linux kernel metrics, these allocation metrics, these cost metrics, et cetera. So Prometheus and other PromQL solutions work incredibly well for this. Once you start getting to scale though, and you want to do really long window lookbacks, or you want to do this at just big scale in general, we see that doing that with Prometheus directly, or especially something like Thanos that would access remote storage, that can just be really, really expensive, right? So we have invested a ton of time and effort to build this layer, this caching layer, or this layer of ETL pipelines, so that when we were showing those demos and we're doing 7-day lookbacks, or we're doing 30 or 90-day lookbacks, we're only actually querying this ETL pipeline. We always, with our APIs, reserve the ability to go to the underlying time series database. But at scale, that can be just really expensive, right? You're pulling in a lot of TSDB blocks. You're sending a lot of data over the wire. So that's why we just kind of build this once in really small chunks. And then we let you query this going back, whether it's 90 days, 120 days, et cetera. And that's, again, fully configurable. So that same touch point, whether it's the ETL pipeline or the backing time series database, that would be applied to the Kubecost UI, which we just showed. That also be applied to the underlying APIs that UI is using. Everything that the UI interacts with is a RESTful JSON set of APIs. And they're actually super excited, just launched another open source project yesterday, and it is Kubecost, where basically you can see an interface with those same APIs from Kubecost. So you can see spend by namespace, spend by workload, spend efficiency, et cetera, all from the kind of comfort of Kubecost. So that's just one thing that's really important from accessing this data, that when you get to scale, you don't want to be querying Prometheus or Thanos directly. And I think also kind of highlights our philosophy of bringing this data where you are, whether it's Kubecost or Grafana or any other place, using their APIs, piping it to something like Looker, for example. We have teams taking our data and taking it many different places. And we think that's just so important to creating awareness across, engineering teams but also just teams in general. So that's like a super important philosophy that we have with our product and, across our team. So, we just to talk a little bit about storage, everything we've been showing so far in that demo, and also kind of like just speaking generically, that's all been like living off of a Prometheus deployment with just a backing PV. Once teams either get to some complexity or really start depending on cost data, again, because they're doing like a chargeback program where they're actively billing their teams or departments on this, they oftentimes really want to think about guaranteeing that storage. And oftentimes it's outside of the cluster. And I think it's really interesting and important. And it's a little bit different than we originally thought when we first built the product, is that a lot of teams want this data set to, reside totally independent of an individual cluster or even a set of clusters. And I think this is important for teams thinking about costs, is because you truly want to have this holistic picture. If you're running 75 different clusters, you want to be able to see them all in one data set and understand relative cost trends across all of them. And oftentimes the best way to do that is by having, again, like storage totally outside a cluster, so that you don't have to worry about cluster to cluster communication or, security posture across all of them, et cetera. And one of the most common ways we see this done is with Thanos. And this architecture kind of gives a high level presentation of that Thanos deployment. Thanos deployment with a sidecar has this really cool property where it just sits alongside Prometheus and basically just writes data to a backing storage bucket. And then on a master deployment, you can query that underlying storage bucket and have a unified cost, picture of your cost, excuse me. And so what that does is, again, it gets you that holistic view, but it doesn't require you to kind of hook up, connections across clusters, or think about, different providers talking to each other or different regions, et cetera. In this scenario, you can have data from an AWS cluster, an Azure cluster, and a GCP cluster, all in, different parts of the world, right into a single storage bucket. And it kind of just works without a lot of configuration. So that's, just general when we see teams get to like large complexity or really depending on this data, that's oftentimes the like deployment mechanism that we see. And then we talk a little bit about data ownership, which is super important to us. We believe deeply that every team should have the ability to like own and control all their data. When it comes to cost data, spend metrics, this is, from our perspective, super sensitive information, and we want to give teams the right to own this. And the way we think we do that is, one, by being rooted in open source and allowing teams to audit our code, fully open. Our code's licensed under Apache 2. You can modify it if you want to. You can take this and deploy it as you would like. And then secondly is, and you'll see it in that like open source code, is that there's no data egress to Kubecost servers. You can lock down egress in whatever namespace you deploy Kubecost, et cetera. And then again, letting teams set their own data retention and access control model. So with anything like Prometheus or Thanos, you can configure retention or even downsampling in like a Thanos environment. But then you can also limit access to that, right? So whether it's integrated with like RBAC or a SAML solution like an Okta or something like that, we want to allow teams to be able to control this on their own. And again, if they just want to have, say, like a single team or a small set of teams have visibility, then they can do that. They can even lock that down by like, a namespace level granularity. For example, if you only want teams to see their only, their namespaces, for example. So this is super important to us. That we enable that for teams of all shapes and sizes. And we've got a lot of users where that's like critical to them as well. whether it's in a government environment or like a sensitive environment like a finance institution or healthcare, that sort of thing. So it's something we think a lot about.
Can I ask you one really? Okay, well, whenever we get to questions.
Yeah, I was gonna say you can ask any question your heart desires.
All right. No, just because you mentioned data ownership, I am fascinated by all the stuff that's going on right now related to data mesh. And I don't know, have you interacted much with data? I'm just specifically from the point related to data ownership of knowing, all right, we're not going to walk in and find everything all tangled up, legacy code, et cetera, particularly in large organizations, financial organizations, healthcare organizations, sensitive records, sensitive data, things like that, knowing exactly who's got access to what. What are your thoughts on data mesh? Do you have thoughts on data mesh? If you don't, we can talk about something else. Just curious though.
Yeah, I'm unfortunately not an expert on data mesh. Would love to talk about specific aspects of it if you are interested, but I do think that the same kind of entangling of data plays out with what we do. And one decision that we see teams make or kind of wrestle with or grapple with kind of early on is tons of teams are running Prometheus, as we all know. And they may have tons of metrics in there. They're even their own custom metrics, but a lot of different, exporters like pumping data to that Prometheus. And then we come along and say that we've optimized a Prometheus deployment just for cost metrics, right? So we collect, when you look at the Prometheus operator, we collect somewhere in the order of magnitude of 5 to 10%. So 90+% less. And so teams oftentimes had this question of, should I leverage what I'm doing with my existing Prometheus and just, send Coupe cost metrics there? Or should I keep this in a silo kind of data warehouse, but really, backing, Prometheus set of TSDB blocks. And we think it's again, context really matters there. We like to just be open and present the trade-offs, right? And our perspective is if you do want to really tightly control access to this, to the spend data, is actually putting in its own environment is the best way to ensure that. Whereas, once you start putting this in a, unified set of TSDB blocks, it's kind of, it's easy for teams to get access unintentionally even. So that's the kind of.
But like you said, is that if people are just, tripping and falling into this kind of, this is where the question has to be asked, whether it's a data lake or a data warehouse, however it's being set up, who's controlling what, who's responsible for what. And I also think that's something that's come up, with Kubernetes but also with cost control or cost optimization things in general, is having things tracked, having things labeled, knowing who's in charge of what. It's not so that there's any finger pointing. It's just so that if these things come up, that there is visibility and transparency on what's going on there. Yeah.
Totally. We think that's super important. And there's a bunch of different implementations of that, whether it's namespaces or having a CI/CD pipeline, determine an owner or, Kubernetes labels, et cetera. Just that ownership piece oftentimes drives a lot of good behaviors from our perspective. And again, just like you said, it's not, finger pointing, but it's, just knowing kind of where to go if, there's a noisy neighbor or, something is crash looping and, firing off all alerts. There's just, especially when you get to a large scale engineering team with hundreds or, 100+ engineers, our perspective is it just, it helps on a lot of different fronts, cost, performance, even security, to be able to track down issues really quickly.
No, I think it's a really good point. And I think these are things as well too, that from, we had Jim Bugwadia from from Nirmata talking about Kyverno. And a lot of these things, it's not that you have to have a paranoia or, this being obsessed with this kind of stuff, but that you really need to have these things as present as possible from an early stage, and not only when it seems that frequently with cost optimization that it's we're only going to tackle this when there's already a problem. Like you said, if you're already looking at budgets that are going over 100K, you probably want to be considering this to be more in the beginning than, we're going to let it get out of control. Another thing as well too that actually came up in the conversation with Sergio, I'm glad he's here, is that for cost optimization use cases, just from my very limited research, a lot of times companies don't want to openly go out there and say, yeah, we were burning our investors' cash, ruthlessly and irresponsibly. So sometimes perhaps there's not as much visibility about these use cases or success stories as there may be in terms of the quantity of cases that are actually happening. In your particular case, in terms of the stakeholders who you interact with the most, are they finance people? Are they DevOps people? Are they engineering managers? Are they junior developers? Who do you interact with the most? When is it? All right, we got to call Webb. We got to get Kubecost on board. How does that go down?
Yeah. I think first and foremost, we totally agree with you that like, once the like fire is already there, once you realize that you're overspending, like some damage has already been done. Whereas if you kind of put these guardrails in place first, oftentimes again, you can save, 30, 50, sometimes, more than 50%. But we also realize that like, we have lots of, requirements and lots of things lots of priorities and that doesn't always happen. Right. So we do see a lot of teams that they're spinning up a new like Kubernetes platform in their environment. And they know they want to get these guardrails in place first because they've heard the like, horror stories or war stories of other teams accidentally overspending. But we get that like, that's not always reality, right? Sometimes it does take a little bit of pain or like, a little overspending to realize that, hey, we really need to, do something and get better here. And I think there's a real self-selection like bias here, but like when we build products, we like to build products for the team members or the teams that are going to be taking action, right? So the ones that are actually going to go and right size infrastructure or turn down idle pods or like, unprovision, like abandoned resources. All of these things are actually going to drive spend reductions. And we have this, philosophy or strong belief where if we build products well for those taking action, then we get a bunch of really nice byproducts, which are like great reporting for finance and management and, great, like easy to implement and easy to understand chargeback programs, all these things. So I think because of that, focus of ours, we oftentimes start with the team or the like DevOps team, infrastructure engineering team that's like managing the infrastructure or managing the clusters. And, they can just helm install our product and get visibility, within a couple minutes. But we very quickly go to like other parts of the organization from there, right? They share that with management.
That's it. That's what I'm saying is that, and this is also why, that in some ways to alleviate or take a weight off the shoulders of the infra team, of the engineering teams, is that, this is a company-wide thing. There are going to be more than a couple of folks that are going to be affected in the same way we're talking about data responsibility, ownership, governance, et cetera. One thing, we got two questions. You mentioned chargeback. Someone asked me earlier, can you go over the difference between a showback and a chargeback?
Yeah, absolutely. And there can be nuances here, but a showback would just be when you're taking allocation and actually presenting it to teams or departments across the organization, right? So you would say, hey, Team X, you're spending $5,000 a month. Here's how it's trending. It's really just about creating transparency, right? And awareness across the organization. Then you move into like a chargeback program and you're truly here like creating an internal economy or an internal like accounting system where you're actually billing those other teams, right? So this could actually be tied into their P&L and potentially their bonuses and your performance ratings and all those things, right? So like that's a much more like sometimes involved, but like serious effort again, where it's actually tying in with like an internal finance system or metering system, et cetera.
Okay, good. Next question. Well, it's a comment first. Amazing session, Webb. And can we create a custom graph where I can select a bunch of different namespaces or pods, and it provides a consolidated cost?
Yeah. So there'd be a number of ways to do this. In our product in particular, so like in the UI I just showed you, you could do something like grouping by label. So you can, label things at the workload level or the namespace level, and then have an aggregation of, any set of labels. You can filter by label, et cetera. But then we do have a lot of teams running our product alongside a Grafana. And like with a Grafana, you could do, anything that you desire, right? Within the confines of any Grafana chart data source that's available. So I would say from our perspective, the controls and the customization in our product typically we aim to meet the 80 to 90% use case. But then there's always going to be some other customizations that are better suited in kind of a full service, dashboarding solution like Grafana. We love Grafana. We don't plan on kind of, trying to rebuild that kind of full set of, drag and drop, fully customizable dashboarding solution. Happy to share more if you have a specific use case. But that I think is the most common patterns that we see, is that most things can be met in our UI, but again, lots of customizing available in Grafana.
Okay. In terms of next steps that you see for Kubecost, apart from the fact that you're hiring, what's on your roadmap for, you mentioned the important news that came out recently, but what else is on the roadmap for Kubecost in the coming 6 months, let's say?
Yeah, lots of things. So you just saw we launched Coupe Tail Costs yesterday. Going to be releasing more open source projects. And you can think about that as both kind of on the visibility side, but also on the optimization side. We're looking at integrating with more providers. Right now, I mentioned we're AWS, Azure, GCP, going to be looking at doing some additional billing integrations. We are doing a bunch of things to continue to provide faster and faster response times at really, really large scale. I'm talking about environments where you have millions or 1 million plus pods running. We plan to invest a lot more in governance as well. So kind of the most commonly used governance solutions today are this notion of recurring reports, which could be used in a showback or chargeback program. Our alerts, we are setting team budgets, et cetera. We just released another feature, which is anomaly detection, which is basically detecting when spend is not consistent with historical trends, patterns, et cetera. Plan to invest heavily there in just better kind of real-time alerting. So lots to come. Let us know if you have specific roadmap questions. We love talking about kind of feature requests and new requirements.
Okay, we've got a question right here. Does Kubecost expose its own APIs to mine the cost data?
So we everything we've showed you, all of our data is exposed via APIs. Our UI just uses our underlying RESTful JSON APIs. So absolutely, that is both from a visibility perspective, just seeing spend by any kind of aggregation, also efficiency. Then we have these savings APIs where you can both kind of ingest that to pipe it to another tool, but we also have teams actually taking action on our recommendations for requests or limits or cluster right sizing. So yes, let me know if you have a specific use case in mind, but the way we build our products is that anything we build on the front end, we want it to use a publicly available API.
Okay, good. Alrighty. I have a question. Okay, this is more of the, historically speaking, all right? Because this has come up more than a couple of times in our meetups, is that particularly because, our community is data on Kubernetes. So we talk a lot about, storage, stateful sets, running stateful workloads, databases, et cetera, on Kubernetes. And one of the things that's mentioned is that in the initial phases, and this is where I'm really curious to get your feedback on it, as much as you were privy to whatever the situation was, that Kubernetes, and I would imagine by extension, Borg, were not designed with with statefulness in mind. When you were working in Google, working on Borg in the early days of Kubernetes, what was the situation? Do you recall any, I feel like a lawyer, do you recall any conversations that you may or may not have had? But what was the deal? Or in your experience, did that kind of come up? Does it feel like we're kind of shoehorning the data question in? It does feel like, this is now meetup number 42 or 43. We are finding more and more folks talking about, like I said, running stateful applications, workloads, databases, et cetera. But in your experience, when you were at Google, were there conversations that you remember about that particular topic?
This is an area where I can't call myself a true expert. I think it's safe to say that I wasn't, quote, in the room where that was happening in the very early days by any means. I can tell you my view on it, which there's some assumptions on mine and also kind of some speculation. So I definitely defer to Joe Beda on this. In that very early kind of thought. My perspective is that there was a little bit more attention given to workloads that were less dependent on data storage. We also see more and more attractive solutions for doing that in a bunch of different environments, whether again it's in cluster or out of cluster storage. Yep. But I also think it was my perspective is they did a really good job of just saying, let's build the underlying abstractions or modules and let's build them as independent subsystems. And at any point, if you want to layer storage on, you're going to have n number of paths to layer storage. So I think there wasn't any any intent to say, let's neglect, stateful workloads by any means, but it was more let's build the platform and the underlying modules and allow you to plug in and, let 1,000 flowers bloom.
Exactly. And that with the idea, knowing fully well that this is going to evolve, there are going to be, add-ons, additions, releases, and now when you look at over, I don't know how many hundreds of thousands of people have participated in Kubernetes. But the pull request reached 100,000 a couple months ago. But anyway, I'm just saying now as all open source projects, it has its own evolution. Like you said, let 1,000 flowers. Well, that's a nice expression. Anyway, sorry, continue.
Yeah, no. I think, again, and that expression, in my opinion, is very much a Google approach for building products, which is, experiment. It's okay to even, have two different iterations on solving the same problem, right? And letting kind of the users or, the market kind of determine the ultimate answer. So yeah, I think, not that they were intentionally looking to neglect anything. I think it was, build the kind of raw tools to be, built on top of. And again, from our perspective, we do see just more and more teams doing interesting things, whether it's in cluster or out of cluster. I think we're skewed to a certain degree because the problem set that we're looking at, it's so important to have this unified view of all of your clusters and then have metrics stored in a way to where you can see that unified set really easily, that we see a Thanos or a Cortex that would have kind of external storage, typically on, block storage, an S3, for example.
Okay, good. I have one final question before we get to the very end, and this is the most serious question. Webb, has anyone ever told you that your accent slightly resembles Matthew McConaughey's?
That has been mentioned to me once or twice. Okay. I grew up in South Carolina. I've been in San Francisco for, going on 10 years. It sounds like I have not lost the accent just yet.
That's great. I think it's amazing. Anyway, I don't think I'm that original for discovering it. I imagine somebody else had probably mentioned that before. Anyway, Webb, one last thing. Can you stop sharing your screen so we can share ours?
Absolutely.
Because as our little final roundup, we always got to mention. Oh, and you didn't even mention, what roles are you hiring for?
Yes, great question. We are largely hiring across the board. So we actually just raised a round of funding from the team at First Round, who's amazing. So hiring engineers, solutions engineers, support engineers, really focus on growing the engineering team. But we're also kind of building up our first go to market effort where we're hiring like account executives, et cetera. So really across the board, growing the team. We're 12 today. We expect to be, double that plus pretty soon.
All right. That's exciting stuff. And if people want to find out about that, go to the webpage, social media, where do they find?
Yeah. So Kubecost.com, on the About Us, we'll have a link to open roles. And then I'd love to share them with you, Bart. And you can also reach out directly to me if you're interested in learning more.
Good. All right. Well, as tradition, I'm going to stand up again because it's fun to stand up. I've never done this before the meetup. We always have someone who's lurking in the background, who's Angel, who's our graphic recorder. And so he's been creating a visual representation of all the things you've been talking about. So Gorka, if we can share our screen to take a look at what Angel has created. Let's see. There we go. We have all the different elements. Well, not all of them. There was a lot of stuff that was mentioned, but quite a few different things that were being depicted there. Like I said, I think it was very, very complete. Really liked the demo. We had some great questions from the audience, touched on a lot of the different things. I think there's more than enough that we can have a second or third or fourth conversation about this. We were talking before we got started, maybe getting your CTO on. I think there's a lot to be said as well, too, that I would like to take further about hybrid cloud, multi-cloud, the different sorts of things that are coming up with that. And also, for folks out there that might be a little bit, thinking just about price tags or cost issues, how can they be more comfortable when moving into this Kubernetes space so that it's not so overwhelming, and not, like you said, focusing on those horror stories of, oh, I heard so-and-so burned a ton of money. So that's why we're sticking to, monolith legacy, keep things as they've been up until now. And, if it ain't broke down, don't fix it. So anyway, Webb, thank you very, very much. That was an action-packed hour. We will have the recording of this up soon in case somebody arrived here late. For everything else, jump in our Slack. We'll be sharing those job adverts. If you have any other questions that you'd like to ask Webb, he's very accessible, reachable, easy to interact with. Anyway, Webb, thank you very much.
Thank you so much. Love the graphic there. Love being here. Thank you so much for having me, Bart.
Our pleasure. Take it easy, man. Have a good one.
Bye-bye.
Bye-bye. Cheers.